write as a single logarithmic expression. 2 log base 3 of x plus log base 3 of y minus log base 3 of z. How am I going to write this as a single logarithmic expression if I have it all in expanded form? I am here with Chloe with her latest cheat sheet notes. She wants you to know that exponential form is when a equals b to the x power. Log form is log base b of a equals x. When you have log of a, it really is log base 10 of a. We just don't write the 10. When you have natural log of a, it's really natural log base e of a or log base e of a. We just don't write the e. The product property of logs is when you have the log of m times n, you can break that down to log of m plus log of n. The quotient property of logs is when you have log of m divided by n, you can take the log of m minus the log of n, and n cannot equal 0. The power property of logs is when you're taking the log of m to the p power, you can go ahead and pull that exponent down and put it in front, and then write log of m. Now that I have Chloe's cheat sheet notes, I can go ahead and write this as a single log expression. So first of all, I'm just going to write the expression down that was given to me. 2 log base 3 of x plus log base 3 of y minus log base 3 of z. From here, I notice that these two on the right in the middle, they just have the log, but the one on the left has that 2 in front. I'm going to go ahead and move that 2 back to the exponent position. If you come down here to the power property of logarithms, you can see that when you have a number in front, like this p right here, you can go ahead and put it back into the exponent position. So what I'm essentially going to do is take that p, put it right up here as the exponent, and that's how I'm going to get m to the p. So I'm going to go ahead and take that 2 and put it right back into the exponent position, so it will become x squared. So I really have log base 3 of x squared. Now I didn't change the plus log base 3 of y minus log base 3 of z. Those all stay the same. But now notice everything is in log base 3 form. They're just taking the log base 3 of 3 different things. Now I'm going to go ahead and do my order of operations. I have addition before subtraction, so I'm going to do my addition first. Notice how I have log base 3 of x squared plus log base 3 of y. On the product property of logarithms, when you are adding 2 logs together with the same base, you go ahead and multiply what you're taking the log of. So on this one, I have x squared and y. Since they both have the same log base 3, I can go ahead and write log base 3 of x squared times y. All I'm doing here is when you have an m and an n and they are the same, you just multiply them by each other. That's if they have the same base, and we do have the same base of 3 on all of these. Now I'm just going to go ahead and bring down that minus log base 3 of z. I did not do anything with that. Now, according to my order of operations, I'm going to go ahead and subtract. Remember, my goal is to make a single log expression. Right now, I have 2 different terms. I still need to make it into one single term. So when I am subtracting, I can come over here to the quotient property of logs. In the quotient property, I can see that when I am taking log of something minus log of something else, as long as they have the same base, I can actually divide those. So I have log base 3 minus log base 3. I'm taking x squared y and a z. I'm going to go ahead and divide those. So when I do that, I have log base 3 of x squared times y divided by z. Now, you don't actually have to write the parentheses here. You can drop those parentheses in the end. So we have log base 3 of x squared y over z.